So we knew these. Anytime that you bake something, you are usually denaturing protein, which means you're breaking down the parts of the protein. So like Toby said, we could have albumin in eggs that is being denatured, that's cooking the eggs. We could have, there's different types of protein in flour.
What's albumin in eggs?
Albumin is the type of protein that's found in eggs. And yes, happy. That's away. Eater too. That's away. And there's types. No, you're done now.
I'm almost done.
Peter, I already have 2 people spending attention with me for 40 minutes. Half and 2.
I'm almost done.
I said I already have people spending 40 minutes attention with me, so put your book away.
Right.
Okay, thermal energy. Excited, hot atom, laid back, cool atom. Thermal energy, like we said, is the energy of heat. The heat energy of an object determines how active its atoms are. What do we mean by active? An active atom. Emma, what do you think an active atom would be?
Atom that is active.
Constantly moving and bouncing
Always
around.
moving and bouncing around.
Okay, so it is the motion of the atoms, okay? So, Jacob,
Yeah.
what would we expect if something had a great degree of thermal energy? What would we expect about its atoms?
Oh, they're bouncing around everywhere.
Okay, so if they're bouncing around a lot, what does that mean about their
It's
position?
probably in a liquid or gas state. I don't know.
Oh, even better. Okay, so probably as we add heat, it's going to create a phase change based on thermal energy. So, Ashley, those elements that have a low amount of thermal energy, what would you expect about their phase? If it's low thermal energy. Exactly. Okay. Not all the time, but we can associate thermal energy with changes in the phase because it has to do with the movement of the atoms, and so does the phase. Okay, so let's have like
I want to go.
4 individuals up here.
Morgan.
Okay, and Toby. Sorry, Matt. I thought Toby first.
Haha, Matt. I don't even know what I'm doing.
Okay, so with your bodies, and be kind, or wine, okay? So, can you please show me what you would expect a solid to look like? You guys are all the atoms. Show me what you think a solid looks like. Come on, friendly atoms. Okay. So, what's your move? Wait, but, so, I don't see you moving. Does that mean that atoms come to a stop in a solid?
No, they're just making moves.
Okay, there you go. Good. So, they're moving around a little bit, but not very much. Okay. They're more vibration. More of a vibration thing.
More vibration.
You're vibrating. Okay. Can you show me what you would expect a liquid to look like? Okay.
Not all the way out. No.
Nope. You're just individual atoms in a liquid. Okay. Okay. And what would you expect atoms in a gas to look like? Go ahead. Go crazy, gas. Good. So we can see. Thank you. Although I think you were the best gas mole.
You want an active atom?
What?
You want an active atom?
Yeah. Right? That's what happens in a gas. I'm giving you lots of thermal energy. You become a gas. Your motion is quite crazy. Okay. Well, that was pretty good. Thanks, guys. You can sit down.
There you go. That was awesome.
I'm on that thing, guys.
Epic.
So wait, object molecules, molecules will show less movement, and that's kind of what we saw is that it does have to do with phase, but we could also see that a cool object, it slows the movement of the atoms as well. So hence why freezing can occur. What would be a type of object that would be really good at... Actually, I'm going to need different volunteers.
Oh, dang it.
Different volunteers. Jacob. Okay, Amber. I need like one or two more. Amber. Okay, Amber. Someone who wasn't up here.
Yeah, I wanted to look like that.
Okay, make a line.
There's 5 of them. So?
Oh, is this the hip one?
No. Well, we can. Sure. Okay. I want to be in it.
Okay, Matt. We're hipping it.
Okay. Okay, class. Hold on. Class. What structure, what phase do you think, hold on. What phase do you think that this type of structure, like they're standing in, would most represent? Based on what Emma and... Solid, right? Okay, so this is showing us a solid. Now, if I give Morgan here, if I give Morgan some heat, if I give Morgan some heat right now, some heat energy, okay? Wow! So what do we know about a solid and heat? They move.
They connect and transfer energy.
They connect and transfer energy better. So we have quite a bit of heat transferring here. Okay, now show me the structure of a liquid.
A little bit space out. Not.
Okay. Okay. But okay, good example. Okay, pause. Okay. The first one was better because it was close, and it was easier because Morgan, how much energy did you need to accomplish that? But was it more or less than the time before?
More.
You had to jump, kind of.
You're
And you had to
going further.
Yeah, it was more.
Okay. So, would we expect that, in general, would we expect liquids to conduct heat better or worse than solids? Thanks, Stephanie. I got one student with me.
Yeah.
Okay. It was harder for them to conduct the thermal energy as a liquid.
Gas.
Now show me a gas.
Everybody start! Jacob, farther.
You missed! See, exactly, and atoms can miss too. They might not bump into that next atom, and they might not be able to transfer it. But, does this look like a very good gas? No. I don't know about the motion of atoms in a gas. Okay, now try. Now we can conduct heat. Okay. So, it took a lot more energy, right? It wasn't so easy. Okay, go for it. You guys can sit down.
Jacob, you're just like, oh.
Go ahead. Okay. So, we know that what are the best conductors of thermal energy?
Solid and liquid.
Was that easy for you to bump into someone? Solid, okay? However, there's a particular type of solid that's best. Think about solids you've encountered and what feels hot when you touch it. Metals would be the best conductors of thermal energy. Okay.
Quiz time.
Quiz. What type of energy? Microwaves, which is what type of energy? Mechanical?
Thermal.
Oh my gosh.
It's chemical.
Jessica, what type of energy cooks food in a microwave? We said microwave. What type of energy is that?
You have potential, mechanical, electro, electrical, chemical, and thermal. Good thing it has a lot of choices.
Not quite. Yes.
I got it. I got
Can you
it.
say it a little really loud?
Electromagnetic.
Electromagnetic, because it's part of the electromagnetic spectrum. Electromagnetic energy. Yes, thermal energy.
Mechanical. I know it.
Well, what we think of, okay guys, pay attention. What we think of as cooking is denaturing proteins. Cooking meat means that you're breaking down the proteins. Cooking eggs, you're breaking down the albumin, which is the protein. Cooking flour or any kind of baked goods, you're breaking down the protein in the flour. So cooking is a relative term. It represents, when we say heat, that means thermal energy. When we say cooking, we mean chemical energy.
So would that be like my science experiment with the vitamin C?
Hold on. Yes. Carney, what type of energy is the spinning plate inside of a microwave oven?
Mechanical.
What?
Mechanical.
It could be an
Electro
example of
or
mechanical
electro.
or electrical.
But it's mostly mechanical.
Mechanical.
I was right.
We're all right. Quiz
Okay,
time.
next person. Chrissy. Electrical energy is transported to your house through power lines. When you plug an electric fan to a power outlet, electrical energy is transformed into what type of energy? Okay, physical's not our name.
Solid. Potential. Oh wait, liquid potential.
The options are in your notes. Yes.
I know this one. Liquid.
Jake?
Potential energy.
No.
Electrical energy.
It's thermal.
Yes.
Did I get it right?
Physical is the right idea, but the word is not physical, it's mechanical.
Oh, it sounds like doing a motion.
Ain't it awful?
Karen, what energy transformation occurs when an electric lamp is turned on? It goes from electrical energy to... No one's answering except Karen. What do you think?
Yeah, we just like heat.
In a way, it's losing some of the energy to thermal energy, so that's half true, but what's the main form? What'd you say? Electromagnetic, because it's giving off light, which is the visible spectrum.
Yeah, but it doesn't give off light.
It does give off some thermal energy, though, so that is that's kind of what we call a byproduct. It's not the goal. There's a little bit of loss to heat.
Yeah, but
You make the light, you have to keep it constant.
Hey, Amber Nelson, what types of energy are shown in this picture?
It's Amber Nelson.
Yeah.
Can you take the picture?
Yeah. Yeah. And by the way, what forces do we see here?
Friction
Friction. Good.
and force.
And what force he's applying? Okay. Mechanical and thermal, because thermal is due to the friction. You're losing energy to friction. Okay.
half right.
Okay. Let's see who's next. Toby.
I don't know that one.
What type of energy is shown below?
Chemical.
Chemical.
Oh, man.
Right? Because the plant is undergoing what process?
Photosynthesis.
Photosynthesis,
Structure is
which is a
changing.
type of, yes.
That is easy.
Okay.
Really girly.
Jacob, what type of energy is shown?
Electromagnetic.
Electromagnetic. Specifically, it is
15 seconds.
Oh my god.
And it could be 12 seconds.
Okay, Tori, what type of energy is shown below?
If you were 5 seconds.
Visible light. Visible light.
3.
2.
Hold on, I got